Okay, we're back with the second video for Chapter 4, Applications of Derivatives. This is the official Lesson 1. We're going to use the first and second derivative tests to sketch the graphs of functions. And to do that, we're going to go through this 7-step process. And I've got step 1 all set to go here. So here's example 1. It says we want to graph f of x equals x squared plus 2x minus 8. Now, here's the deal, guys. This is quadratic. You could have graphed this in Algebra 1 or Algebra 2, but we're going to come at it now from a different standpoint, a calculus standpoint. So some of those old graphing techniques like finding the vertex, we're not going to be doing that in the same way you would have done it in those past math courses. So from a calculus standpoint, we're going to go through these 7 steps. So let's take a look at step 1. It says identify the possible critical points. Let me circle that, on the graph of f of x. Now from our prior lesson, we defined critical points as places on the graph where the slope is 0, creating our maximum or minimum. So all you do to identify those is take the first derivative, f prime of x, and I'm just going to use shortcuts here. The derivative of f of x is going to be 2x plus 2. And I'm just going to set that derivative equal to 0. I want to know where the slope of my tangent line is 0. And solving this, I'll subtract my 2 over, giving me negative 2 equals 2x. I'll divide both sides by 2, so I've got that x is equal to negative 1. Now, critical points are going to be ordered pairs. So we have the x value for the ordered pair. Now we have to go ahead and find the y value. So we need the x value and the f of x value. So I'm just going to take negative 1 and plug it back up here into my original. So f evaluated at negative 1 is negative 1, backwards, negative 1 squared plus 2 times negative 1 minus 8. And that will give me negative 9. So I'll feed that up here. So my critical point is going to be negative 1, negative 9. I know the slope is 0 there, but now I need to analyze, well, what's happening to the left and to the right? Am I increasing and then decreasing, or decreasing and then increasing? Do I have a maximum, a minimum? What's going on? And that's why I go on to step 2. Step 2 says, create a chart relating the sign of f prime of x to the behavior of f of x. So this is what the chart's going to look like. You're going to put down f prime of x, and right underneath it, you're going to put f of x. In between the two, you're going to put a number line with an x here. This will never change. From problem to problem, the way this looks is the way it will continue to look. What will change is what you put on the number line. For this particular problem, we're going to put negative 1. Our x value from part 1 was negative 1, so this is our critical point. And what I want to do is evaluate what the slopes of the tangent lines are doing to the left and to the right. So I'm going to choose an x value situated to the left of negative 1. So I might choose x equals negative 2. Once I choose x equals negative 2, I'm going to plug that into f prime. So f prime, when x is negative 2, I have to go back up here to f prime of x. F prime of negative 2 is going to be 2 times negative 2 plus 2, which is negative 4 plus 2 is negative 2. So the sign of my derivative, the sign of my slope, is negative when I'm to the left of negative 1. Now I'm going to pick an x value to the right of negative 1, maybe 0. F prime of 0 will be 2 times 0 plus 2, which is 2. So the slopes of my tangent lines to the right of negative 1 are positive. Now let's think about what that means on the graph. If my slopes are negative, and then 0 at my critical, and then my slopes turn positive, then I've got a minimum critical point. Because these negative slopes tell me that my function is decreasing and then increasing. So this is what I've got going on. So now when we go to step 3, which says state the type of critical points you have and justify, I can say a minimum occurs at, now this gets interesting. I go back to my critical point, -1, -9. The lowest this graph is going to go is the y value. So the minimum occurs at y equals -9, since, this is my justification, since the sign of f prime of x changes from, look at your chart, negative to positive, negative to positive, when x equals -1. So I'm definitely getting both coordinates in my answer, -1, -9, but the minimum value is actually the -9. Okay, let's go to step 4. Step 4 says identify possible inflection points on the graph of f of x. Now we learned in the previous video that inflection points are determined by the sign of the second derivative. So I am going to do f double prime of x. If I take the second derivative, I'm looking here at the first derivative. The derivative of 2x plus 2 is just the constant 2. So when I try to set 0 equal to 2, just like I set 0 equal to my first derivative, I set 0 equal to my second derivative, what ends up happening is 0 doesn't equal 2. This is a false statement, and there's no x to solve for. And what that means is there are no inflection points. Since this is quadratic, it makes sense that there would be no change in concavity. So no inflection points for step 4. Okay, step 5 says create a chart relating the sign of f double prime of x to the behavior of f of x. This chart is going to look exactly like the chart from step 2, only it's going to be an f double prime chart. So it'll look like this, f double prime of x, f of x. Now here's what's interesting. We don't have any x value to put on here because we have no inflection points. That's okay. I don't have to put anything on here, but what I can say is this. The second derivative, being that it's a positive constant, is going to have a positive sign for all x. And that just tells me that I'm always going to be concave up. Excellent. Okay. Number 6. Number 6 says find the y-intercept of f of x. Well, that's easy to do. The y-intercept is just given by f of 0. So going back to the original function, f of 0 would be 0 squared plus 2 times 0 minus 8, or just negative 8. So y-intercept 0, negative 8. Okay, putting all of this together now, step 7 says sketch the graph. So putting this all together, let's draw an f of x axis and an x-axis. There isn't too much to go through here, but let's take it step by step. Step 1. In step 1, we found the critical point to be located at -1, -9. So I'm certainly going to put that on my graph. -1, 1, 2, 3, 4, 5, 6, 7. Extend that a little bit lower. 8, 9. Okay, so -1, -9 is my CP, my critical point. Okay. I also found that I have a y-intercept at 0, -8, so I'll put that on. And those are honestly the only 2 points I really found. The rest of this is just telling me the direction of my graph and identifying the type of critical point that I have. So basically, I can look at this first chart here. I know that at -1, -9, the slope of my tangent line is 0. And I know that to the left, my slopes are negative, and to the right, my slopes are positive. So I'm just going to come decreasing negative slopes, turn, increasing positive slopes. Voila, I'm done. Now I can also check steps 4 and 5, I guess, to see, am I truly concave up all the time? And I am. I'm definitely concave up all the time. So that concludes it. So I just have my little quadratic function here, but I graphed it totally differently than I would have in Algebra 2. Okay, on the next video, and the final video for Lesson 1, I'm going to tackle the back of this worksheet. Examples 2 and 3, I want to get into some cubics.